Hey guys, welcome back to Ryan and Billy's Cubing, and today I'm going to be showing you how to solve the mirror cube. So this basically has the same mechanics as a normal 3x3. You turn it the same way, except for it shape shifts a little bit because the pieces are different sizes instead of different colors. So it will shape shift as you turn it. So this is going to be a bit more difficult to solve than the standard 3x3, but really it's the same concept. So I'll be back in a minute once I've mixed it up. So this may look intimidating at first, like really intimidating, but it's not, because it's the same thing as a 3x3. So I'm just gonna you want to find your thinnest side first, and that appears to be this side. You can check this by finding one of your thinnest pieces, so I have one right here, and then rotating it to the top. If it's flush with that, see, it's kind of hard to see, but it's flush there. It's the same thickness, so that you know that that's your thinnest side because that also is one of your thinnest pieces. So now that I have a thin piece at the top, or one of my thinnest pieces at the top, I can just rotate it around until I find another area where it's flush. So it's flush right there, and it's flush right there. So that makes one piece of our cross. So now let's look at our bottom face and see. So we have two of the thinnest pieces on the bottom face, one right there and one right there. So we just want to rotate the pieces around until one of them lines up. And there's one that lines up. You want to rotate your pieces around the bottom. So it lines up there. So I can just rotate this twice to get it to the top, and now we have two pieces of our cross. And you can also do this with this piece, which gets us our cross there, or the third piece of our cross. So now that we have three pieces of our cross, I look on the bottom and I see we don't have any pieces that will match up with the thinnest side that are currently on the bottom. So either we get them to the bottom by doing this algorithm and then rotating them around, and there that is, or let me get it back. We can improvise a little bit, which is usually what I like to do. So in this case, so we want to rotate this. So this is the only possible center that this could line up with, because all the other three centers that are adjacent to this one are taken. So we want to rotate this to be the same distance between these two that this center is between these two, which means that this center is in the middle of this one, therefore this edge must be in the middle of these two edges. So we just want to get it there. So you can rotate your top face this way, rotate this up, and then rotate this over, and there that is. So there is your thin cross. So now we need to get our thin corners. So this is the same algorithm as we would do on the 3x3, the normal one. So you can rotate your corner around the bottom until you get it to where it needs to go. So right here, so it gets under where it needs to go. So we put that there. We do our same algorithm, rotate right face down, bottom face this way to the left, right face up, bottom face to the right, right face down, bottom face to the left, right face up, bottom face to the right, right face up, bottom face to the left, right face up, bottom face to the right, right face down, bottom face up, or bottom face to the left, right face up, bottom face to the right, right face down, bottom face to the left, right face up, bottom face to the right. And now that corner is solved. So now we need to do that with all of our other corners. So in this case, if it looks like you can just rotate it up, I had the wrong corner there. So if it looks like you can just rotate it up, there's a different algorithm that you can do. So you can just rotate this out of the way, all right? and then rotate this down, and then rotate this over. See, so now those are lined up. And then you can just rotate this up. So just feel free to get experimental with this, and this part is mainly intuitive. So in this move, I got this to the bottom, the way that I taught you guys. So now I'm just gonna rotate it over here, and right face down, bottom face to the left, right face up. So if you haven't already seen my 3x3 tutorial on how to solve it, be sure to check that out. I will leave the link in the description. And, you know, if you found that helpful, leave a like and subscribe if you haven't already. So now that I have 3 of the corners solved, I need 1 more. So I can do the algorithm that I've been doing. Down, over, up, right face down, bottom face to the left, right face up, bottom face to the right, right face down, bottom face to the left, right face up, bottom face to the right, right face down, bottom face to the left, right face up, bottom face to the right, right face down, bottom face to the left, right face up, bottom face to the right. And now I have the side solved. Okay guys, so now that we have a face solved, we want to put that face on the bottom so that we don't mess with that yet. So before we do anything, we just want to look around the top face and see if we have any edges that are flush with one side. And it appears that we have, and keep in mind that I'm talking about the middle centers. So we have this one and we have this one. So I'll just choose this one to work with right now. So this one is already solved, this one right here. So we want to get this one into the only other place that it could be, which is right here. So to do that, we rotate this away, this up, this over, and then our corner's back here, so we need to rotate it down to match up with this. So now we have our corner and our edge lined up, so we can just rotate this way, away, so that we have room to rotate that up, and then rotate this like that, so that now they're matched up. And now you just need to do one more move, which is rotate this part down. And see, our side is still fixed, and now we have 2 of our edge pieces. So now we look around. See, we don't want to move this one right now because, or we don't want to move this one down to the bottom because it matches up with our top center. So we don't want to mess with those pieces. So we can just rotate this piece around until it matches up with one of the centers. And it's matching up with this center right now. So we can just rotate it away. We can rotate this piece up, rotate this piece back towards the center, rotate this piece down, and see, that does match up with the center. So then we can just rotate this piece this way to give us room to do these moves. And see, so now there's our 3rd edge solved. So now we need to find our 4th and final edge on the top. And we see that it's right here for me, so I just want to rotate this till that happens. Okay, here is our 2nd case. So this piece needs to go here because it can't go here because that's already solved and we don't want to mess with that. So we just want to rotate this piece here. So we rotate this piece away, we rotate this piece up, rotate this piece back towards it, and then we rotate the corner down. So now we have to get this back here. So we just rotate this towards where we want it to go. Rotate the front face this way. Rotate this piece this way. And then rotate this piece down. And now we have our middle layer solved. Alright guys, so now that we have our middle layer solved, we need to solve our yellow face. So this is going to be a bit easier than the other ones. It's just the same algorithm. So you want to rotate your top face until you have, if you have the L case, then you want this piece to be pointing this way and this piece to be pointing this way, so that you can do the following algorithm. Front face this way, top face to the left, rotate this piece this way, because you're replacing this piece with this piece, so that you can rotate this piece this way. You can now bring it down, and there's your yellow cross. So now that we have our yellow cross, we want to get our corners. So here we don't have anything solved, so just pick a side, or yeah, just pick a side. I'll choose this one. Wait. So I need, the algorithm is you rotate this piece up, this piece over, this piece down, this face this way, this face up, and then you can rotate this in either direction twice, and then rotate this piece down. If you know the algorithms for the 3x3, you should be able to solve this on your own, but I'm just walking this. I'm just walking through this with you, and I hope that you find this helpful. So leave down in the comments if this was helpful to you. So now we see that we have our fish case. It's kind of a lopsided fish, but it's a fish nonetheless. So we need to rotate it so that our fish, the head of the fish, is pointed towards the bottom left corner. And so you can rotate this up, rotate this over, rotate this down, and rotate this over, and then we rotate this piece up, and then we rotate it twice, and then we can rotate this piece down. And now we have a yellow face because the whole face is flush. So now that we have our whole yellow face, or the thick face, or whatever you want to call it, we need to rotate the whole cube so that our two corners that are matched up are facing in the back, but it doesn't appear that we have any that are matched up. So what we want to do in that case is rotate these pieces around until we find two matching corners. There's one that's lined up, but we need two that are lined up. Remember that, two that are lined up. So just keep rotating, and there are two that are lined up. So we need to do the following algorithm to make these two lined up. Right face down, front face this way, right face down, rotate the back face twice, right face up, this face this way, right face down, rotate your back face twice, and then rotate your right face twice, and then rotate it once over. And now your top corners are solved. So now what we want to do is we're gonna rotate these corners around to where they're in the solved position. So you just want to rotate your front face twice to begin with. Now here we can check whether they are correct by just rotating it once in either direction. Okay, this orientation is the correct orientation. I want to show you what to do if you didn't do the correct one, because it's kind of hard to see because the sides are so similar on the mirror cube. So if you rotate it the wrong way, you don't have to keep doing the algorithm. You can just rotate it back so that now these actually are lined up. And so now you want to rotate both of these down. Rotate your front face twice. Rotate both sides up. And then rotate them this way. And I'm sure you can see what to do from here. You rotate this face twice. And now your mirror cube is solved. So now the other cases on the mirror cube are the same as the 3x3 Rubik's Cube. So if you have any questions about those, just either leave them down in the comments or go check out my 3x3 tutorial video and just kind of you visualize this being like a 3x3 with different colors and all that. I'm going to leave the link to my 3x3 tutorial in the description. So, yeah, go check that out. If you liked the video, if it was helpful, make sure to like and subscribe and turn on your notifications so you're always notified when me or Billy posts a new video. Thanks so much, guys. Bye.